Let's take a look at inverse relations and later on a horizontal line test to see if we can find an inverse function. First, inverse relations. Here's a simple XY chart with an original relationship. X is on the left, Y is on the right. To find the inverse relation, we simply invert X and Y. So, what was X will become Y, and what was Y will become X. So notice that all the ordered pairs have been reversed. What was x6, y3 is now x is 3, y is 6. Negative 8, 1 has now become 1, negative 8. 0, 5 is now 5, 0. 2, negative 7 is negative 7, 2. This green list of ordered pairs is the inverse relation of the original purple relationship. They are inverses of each other, and it really is just as simple as reversing x and y or inverting x and y. So go ahead and pause the video and see if you can take this relation and write its inverse with these ordered pairs. This is the inverse relation with all the ordered pairs. What was 2, 4 is now 4, 2. What was negative 11, negative 14 is now negative 14, negative 11, etc. All the x and y values have been inverted. That's an inverse relation. Now, let's see if some functions might possibly have inverse functions. You know the vertical line test that we use to see if a graph originally is a function. So this parabola that we see on the screen is a function. If none of the x values repeat, it will pass the vertical line test. And this graph is a function. Everywhere I might draw a vertical line, I'll cross the graph no more than one time. That's because none of the x values repeat. If any of the x values repeated, then we would hit the graph twice, it would fail the vertical line test, and we couldn't call it a function. This graph includes points like negative 2, 2 and positive 2, 2, and that's okay for a function. It's okay for the y values to repeat. The x values can't repeat. So there's the point negative 2, positive 2, and positive 2, positive 2. That's okay. This graph is a function. But what we want to know is, does this graph have an inverse function? What happens if we switch the x's and y's around? Would it still work out? That's where we break out the horizontal line test. So if a horizontal line passes through the graph no more than one time, it would pass that test and it would have an inverse function. That's because none of the y values repeat. Well, you could probably tell by the first time I ran the cursor through there, this fails the horizontal line test. There are multiple places where we cross the graph twice. That was supposed to be horizontal. And that's because the y values repeat. So there is not an inverse function for this. For example, look at the 2 points we considered earlier. When we had the point negative 2, 2, we reverse that and get 2, negative 2. The point 2, 2 is reversed to 2, 2. But look at this. Here are repeating x values. So if we have y values that repeat, when we switch them up to x values, now we don't have a function. So the horizontal line test lets us know if there's an inverse function. And this one does not have an inverse function because it fails the horizontal line test. What do you think about this graph? Does it have an inverse function? It absolutely is a function in itself. It passes the vertical line test. Does it pass the horizontal line test? In other words, is there anywhere a horizontal line would pass through this graph more than once and make it fail the test? This does have an inverse function. It passes the horizontal line test. Everywhere you go, you'll never cross this graph more than one time with a horizontal line. So it does have an inverse buddy. If you reverse all these xy pairs, it'll work out just fine. You won't have any repeating y's that return into repeating x's. Look at this nifty graph. It is a function, but does it have an inverse function? In other words, does it pass or fail the horizontal line test? It doesn't have an inverse function. It fails the horizontal line test. Multiple places. Just look at on 0. There's 1, 2, 3 places where we go across where y is 0. Sorry, I'm having a tough time going horizontally here. And that means when in an inverse, all those y's would become x's. That's x being 0 3 times with different y's. So it does not pass the horizontal line test. The simple answer is this does not have an inverse function.